Morning. Today let's go a step further with quadratic equations and have a look at ones that include a denominator. So as soon as we have a denominator, we first of all have to eliminate it, which means finding the LCD. But there's another aspect to having a denominator, especially when there's a variable in the denominator. So let's look at the LCD first of all. Remember that because the whole of x minus 2 is under the fraction line, it's acting as if it's in a bracket because the entire thing is in the denominator. So my LCD here is pretty easy. I have a 3 that needs to be represented, and I have the bracket x minus 2 that also needs to be represented. So that's my LCD. So we know that you cannot divide by 0. Dividing by 0 is undefined. This is fine because there's a 3 in the denominator, so we're not dividing by 0. But this, because it contains a variable, depending on the value of the variable, we could end up having a situation where we're dividing by 0. So we need to say that x minus 2 may not be equal to 0, in which case it means that x may not be equal to 2, because 2 minus 2 would give me 0. So I need to write that down straight away, and that is called my restriction. So I have a restriction of x not being allowed to be equal to 2, and if when I've worked out the whole answer I get an answer of 2, I cannot accept it. I need to chuck that answer out. So let's see what we do. We're going to multiply this term and that term by the LCD, 3 bracket x minus 2. So I find the easiest thing to do is to have it written down there on the side, and then you just imagine multiplying this term by that denominator, and then the x minus 2's and the x minus 2's would cancel, and you'd just be left with 3 minus 3, which is, not 3 minus 3, sorry, 3 multiplied by 3, which is 9. Now we need to be very careful about this negative out here. This is saying that the whole fraction is negative. I've already made the 3 positive, so it means that the numerator is negative. But again, first of all, let's imagine that we're multiplying this fraction by the LCD. The 3's would cancel, and I'd be left with the bracket. So I'm going to put minus, and just the same way as x minus 2 could be regarded as being in a bracket, so could x minus 8, because it's all on top of the fraction line. So I've got negative my numerator times what didn't cancel in the LCD, which was x minus 2. Right, I need to multiply out now and then start gathering. Well, first I need to see, is it actually a quadratic equation? Sometimes with these, you can't tell until you've multiplied out the brackets. So 9 equals, I'm going to do FOIL and multiply that in at the same time. So x times x is x squared times the negative is negative x squared. Outers, this will give me negative 2x times the negative will be positive 2x. Inners, negative 8x times the negative will be positive 8x. And this will give me positive 16 times the negative will give me negative 16. So I am seeing that it is a quadratic equation because it contains an x squared term. So I'm going to bring everything to the left-hand side, which will be nice because it will make that into a positive x squared. 2x plus 8x is 10x. Bring it across and it becomes negative 10x. I've got 9, and I'm going to bring this across as positive 16. So 9 plus 16 is 25. And because I brought everything across, the right-hand side is now equal to 0. So I do have a quadratic trinomial, which I can factorize into 2 brackets. So let's try and think of factors of 25. Well, apart from 1 times 25, we've only got one option, and that's 5 times 5. Can 5 and 5 give me 10? Yes, it can. And I'm supposed to be adding, so 5 plus 5 giving me 10 is correct. So setting up my brackets, first of all, I've got x and 5 and x and 5, and and then that tells me the signs in the brackets are going to be the same, and they're both going to be negative. So, because this was a perfect square trinomial, we've actually ended up with two brackets that are identical. So I don't need to say this equals 0 or that equals 0. It's simply x minus 5 is equal to 0, and therefore x is equal to positive 5. Then what I have to do is I need to go back and check my restriction. My restriction said that x could not be 2, but I've got an answer of 5, so it is acceptable. And from a graphic point of view, let's just have a look at what this actually means. We did speak the other day about quadratic equations being linked to parabola graphs. So if I draw up a Cartesian plane here, a set of axes, and I look at my general form of this quadratic equation, ax squared plus bx plus c, I see that I've got a positive x squared value, which means I'm going to have a smiley-faced parabola. And then I spoke about this the other day, and now it's actually happened. If I have a quadratic equation and I end up with only one answer for x, then it means that x is only touching the graph. The graph is only touching the x-axis at one place. So let's say 5 is over there, and then it's a smiley face graph, so it means I've got a graph that's just touching the x-axis, and that's why I only have one solution. It's lovely to always try to relate these to the type of graph that they are, because then they just make so much more sense and it's easier to understand.